I'm sorry for my English, it's not so good. We had some questions if we could do it in English this time. I think for Müller this is no problem, but I'm not that often speaking English, but I can, so hopefully it's good. First of all, question, I see many new people, new faces. Where do you come from which university or company, or yeah. We sent many emails this time, so it would be great if you just raise your hand if I say the company or so, and the rest tell us afterwards where they come from. For example, we sent to HMMH, HMH. Nobody. No, okay. I think it's better. Maybe we do a short round. Everyone tells it's a bit better than I would do. Okay.
I skipped because my introduction.
Yeah, okay.
Follow.
He tells later. Okay.
Yeah, from the university.
Okay.
Yeah, me too.
University of Life Science.
Me too. And I'm for the first time here because Andrew told me.
Okay.
My name is Freund Annicke. I work as teacher
Okay.
in the school for technology.
Dirk Wenig, University of Bremen. I'm a member of the working group Digital Media.
Christian from University of Bremen.
Hey, I'm Cornelius. I'm from England. Our company in Bremen.
Hi, Morgen. I'm coming with him. Look.
I'm Daniel. I'm studying at University of Bremen and working at Anchorway.
Yeah, I'm Björn. I come from the University of Bremen and work at Neustadt.
I'm working also at Neustadt.
I'm Henning and I'm also working at Neustadt.
I'm Jan and I'm also working at Neustadt here in Berlin.
I'm Dennis. I'm from University of Bremen and working for contact software.
Okay, I'm Darko. I'm an ex-student of Jakobs University here in Bremen. Now I'm self-employed.
I'm Stefan. I work with contact software.
I'm Andre. I'm currently studying at Jakobs University.
I'm Malte. I'm working for Werk 85, new young startup in Bremen.
Oh, cool.
Yeah, I'm Andre. I'm currently studying at the University of Applied Science.
Yeah. I'm Henrik and I'm studying at the University of Applied Science.
I'm Steve. For those of you who don't know me, I'm also studying at the University of Applied Science, and I'm also working for Neustadt software development.
Yeah, I'm Matthias. I'm working at NetTV and I'm also studying.
For those of you who don't know, many of you, we're doing a short status report at the beginning of our regulars tables, and I'm telling you just some numbers of the GTUG and what the last events in the last months were like and what's coming in the next few months. And yeah, we start with the numbers. We had 5 regulars tables since now, this is the 6th, and at these regulars tables we had 8 tech talks. If you like to see the presentations or videos of those talks, they are on our website, so feel free. We had 2 hackathons, one between Christmas and New Year, and the other one was a global event from the Android community. Global Android Dev Camp was last month, was it? February, and yeah, we did 2 Android apps during this hackathons. The first hackathon we had an Android app, an App Engine application and a Chrome extension. That's pretty much, and the app isn't finished yet. There are several reasons why. I'll tell you one after some more slides. And at the global hackathon we did a multiplayer game, a multiplayer version of Labyrinth. some of you might know. And yes, if you're interested, you can go on our Google Code page or can ask us to show you something. Yeah. And we had an average of 30 members at our events. How much are we now? Oh, much more. Okay, we have some sponsors. First sponsor, Best Western Hotel, where we are now. They are sponsoring our regulars table. We are always here, always in our room, but always here. And our second sponsor is Jan Stahlmann, is the guy in the corner at the camera. He helps us with flyers, printing flyers. He's giving us beamers or cameras to support us, to give you something. The beamer is always great. And yeah, we have Team Neuster, our third sponsor. Team Neuster helps us with the hackathons. Yeah, a lot. Last hackathon we were in the stadium, Visa Stadium. Great location. Okay. Now we'll tell you something about our last events. In March we had pretty much going on. We had our regulars table and some conferences and so on. First of all, we had the regulars table. We had a talk about Node.js. Malte and Andre and John Philip told us something about it. You can check out the presentation or watch the YouTube video. The presentation is all my presentation. It's already on the website if you want to check the links or something. And if you're interested in JavaScript, you can follow Bremen.js on Google+. I don't know, do you have a website now?
Not yet ready.
Okay.
But will come. Bremen.js.
Okay. Check them out on Google+, and we'll tell you if they have a website.
Isn't there TLD? GS?
No.
Okay. Then there was a conference in Hannover. It wasn't an event from us. We just went there. It wasn't organized by Bremen GTUG, but I think it's a nearby conference, and not conference. Just fair. Yeah. Okay. We were there with some people. I think more of you went there too. And yeah, the highlight from Google was that they presented Google Plus for Google Plus there. Yes. My conclusion was that it's getting more and more a business trade show. Trade show, is it right? Or is it more fair? It's okay. And it wasn't that interesting for me. I speak with a guy from a Python user group in Köln. And that was interesting, but most of the groups were not that interesting for developers, so yeah. Make your own picture next year.
There are other conferences.
Yeah, next one, DroidCon, was in Berlin. It's an Android conference, and it's completely organized by the community. They had some, I won't say problems, but last year Google didn't support them that much. They sent some speakers, but didn't support them with money or so. So this year we had Microsoft as a platinum sponsor for an Android conference, which is a bit tricky, yeah. But it was a great conference. We participated with 5 members, as far as I know. And we had, I think, great times. We were 3 times there. There were additional events from Berlin, Google Technology User Group. And for example, a hackathon the weekend before. And we participated in the DrawCon Monday. That was a startup tour. We visited some startups in Berlin. For example, Six Wunderkinder, Amen, and the third one? Readmine. Yeah. And then one day before was there was a bar camp where additional speakers, presented stuff. Okay. And the last one, I wasn't there. Matthias was there. He won a ticket. Congrats. And blame him. No. So please tell us something about it. How was it?
Yeah, I think the DrawCon was a little bit more interesting. So the DrawCon is a community-driven event, and Mobile TechCon is more a business-driven event. So it's a little bit spießig. But yeah, it's a ticket costs €700. I've won it. Yeah, so it was more professional, but the atmosphere was not so good as it was at the DrawCon. It's not so much community, it's more business.
Okay, that was the last event. Yeah, now I'll tell you something about the upcoming events. Today is the regular table in April. We will have another regular table next month. Yes, every month. At the 7th of May. If you follow us on Google Plus or are on the mailing list or something, Facebook, LinkedIn, Twitter, we'll tell you, we remind you if you forget or something. And then we have an additional event, the Google I/O Extended. Many places, for example Berlin and Munich, are doing Google I/O Extended too. We are We are doing Google I/O Extended together with the Hamburg GTUG, and we are doing it in Google Place, Google Office, yeah. And this will be on 27th till 29th June. Details are not ready yet. Schedule is missing and so on. So we'll tell you.
Maybe you should say what it is.
Oh yeah, of course. I'm sorry. Yeah, it's old. Google I/O. Who don't know what the Google I/O is? Don't be shy. Okay. Google I/O is a conference Google does nearly every year, and in San Francisco they tell what kind of new technologies they have, and you are able to go there. It costs about $900 right now. The tickets were not available 20 minutes after the registration started, so pretty popular. And yeah, many GTUGs are doing extended, where they sit together and watch the talks they have on the Google I/O. And yes, we're doing maybe we're doing a hackathon around this event in Hamburg. Questions about the event? Don't be shy.
So it will be sponsored by Google in the Google office, and yeah, maybe some people of Google will be there.
When does it start? Which time?
We're not sure. Yeah.
I think Google I/O is in America 8 hours.
Yeah.
18 o'clock.
Yeah, we probably don't know yet because the schedule isn't ready. It's in the week. It's a kind of a problem for many people. I understand. Yeah. We can't say that much right now. We don't have the details yet. We are planning it with the Hamburg guys. Yeah, and yeah, we'll tell you as soon as possible. Okay. The next one is.
I've got a question.
Yeah.
Do you plan something for the Google TV hackathon, or is it just a non?
Is the Google TV?
I thought it was a global hackathon about Google TV.
When is it?
I'm not sure about that.
Okay. No, we're not doing it. I don't think so. We have a Google TV here.
Yeah.
Would you like to program something? So.
When you're interested, maybe we could first together on weekend. Yeah.
Yeah, probably would be nice idea.
If you have an event idea or something, just come to us and tell us about whatever, hackathon or global event or the event you have in your mind, and maybe we can.
GTUG London is organizing a global Google TV.
Okay. Fun. Okay, this part of the presentation is new. We have an announcement that's pretty, no, it's not big. It's a change for us, for many Google technology user groups. At the last regulars table, we received an email from Van Riper. I think most of you don't know him. I didn't know him before I started GTUG. He works at Google and helps the Google Technologies user groups to at different parts. He organizes to get I/O tickets or something. And he wrote an email that the Google Technology user groups will have to move from GTUGs.org, where you can find all Google Technology user groups right now, to developer.google.com page. And first there was a big discussion about it. And now it's pretty clear that this will happen. And also the Google Technology User Group is renamed to GDG. GDG is Google Developer Group. We asked some of you on Google Plus how you think about this. There were some negative points in other user groups, but in our user group it's pretty clear that we are going to change our name to Google Developer Group because most of our members were developers and not designers or something. And yeah, the first question, what will be new? We will have a new name. Instead of Bremen Google Technology User Group, we will be Google Developer Group Bremen. And we have a new brand, a new site, as I told. And the rest stays. Our topics, our events will all stay the same. And next question, when is it happening? Yeah, the only thing Van said was that it will be until I/O 2012. It could be pretty soon that the page is ready to move there, but yeah, we don't know yet. But we'll tell you when it's happening. If it is happening. Sorry. Yeah, and the new sign will be like this. That's just an example from Ben. What?
It's an example.
Yeah, that's an example. We would have changed it. We would have created one already, but they will have an generator for this. So. And that's the generator's not ready, so yeah, we are just waiting.
No, you know that.
Okay, that was the announcement. Okay, and yeah, now about today. It's our 6th regulars table, and we have one talk, the Go programming language by Frank Müller. And afterwards we can have an open discussion, or if you like, you can play with my new Google TV. I just received it today, so it's new. It's an old one. Okay, thank you for your attention. If you like to know something about presentations or topics we had, or what is going to happen in the future, just visit bremen.gtugs.org. We have a Google code page where we have these 2 projects we did on the hackathons, and you can find us on Google+, Twitter, Facebook, and LinkedIn. Okay. Yeah. Any questions? No? Then we'll take a short break. I'll ask
Yes, I want to welcome you to my little talk here about Go, Google Go, the new programming language. It's not so new, 2007, later. It's my first presentation with the talk, with the beer. Until today I had nothing or just with water. So, as an introduction, which we have skipped a few moments ago, I'd like to introduce myself. My name is Frank Müller. I'm born in 1965 in Oldenburg, near here to Bremen, for those who are not from Bremen. Yes, I'm doing software development since 1984. It's a pretty long time, and I've learned several languages this time. The newest one is Go. I'm working as an author since 1999, mostly for the Alex magazine, Heise Verlag. I also wrote for Linux Enterprise, and this doesn't exist anymore, and for Java magazine, but mostly for Alex, always about software development, about programming languages, about processes like agile processes, and about tools. And the last larger article has been about the Redis NoSQL database. Yes, and I wrote a book about the Go programming language, which is published at GTUG Verlag. And here I have a little surprise. That even three books. Yes. So we have to get an idea how we will, how we will give them to you. It's kind of buttery.
Next question.
It's mostly written in 2010 and published earlier in 2011, so it's not covering the newest standard. We are currently analyzing how much effort it would cost to bring it to second edition. But thankfully, the largest part of the language itself has been very stable since it has been published in end of 2009. So it's still good. Yes, but now let's talk about Go itself. That's the Gopher. It has been designed by the wife of Rob Pike, who's one of the developers of Go. Renee French, she has also designed the logos of Plan 9 and Limbo, all that other stuff. What has been done by Rob Pike and Ken Thompson. So here you see the starting team has been Rob Pike, Ken Thompson, several of you know the names, and Robert Riesener, who's a bit younger. Yes, they started the idea of building a new programming language in the end of 2007 and had hard discussions about what features will be in this language. But this hard discussion is the reason that this language is so stable until today. And mostly the libraries and packages have been changed, but not the language itself. The core is really stable. Yes, they started in 2008, and then in end of November, or mid of November 2009, they announced Google Go, made it public as open source on Google Code at their own site on it. And in this year, the famous and bad TUG index said Google Go is the language of the year. The index is pretty bad because it's very bad metrics. But that's yes. And last week we had the release of Go 1. That's yes. they done it exactly for this event here. It's pretty nice. So the idea is that while the language itself will, or the libraries itself will continue to be improved, the core will be improved of the language in the sense of the underlying garbage collection, speed, and everything like that. The API of Go 1 will be stable for several releases, and the next bigger release, Go 2, then first to be the API changes. But now, as opposite to the weekly releases that have been during the last 2 years, they released every week a new, or almost every week a new release. This Go 1 is now stable. Yes, I told before, Rob Pike is one of the famous parents of Go. He is in software development for many years, like in Thompson too. They are both, also parents of Unix, of Plan 9. You know Plan 9? It's a successor of Unix with the idea that every communication between processes and devices and other processes have to be done in the same way as you are writing into a file or reading out of a file. So you have a very stable kind of API, and every device, if it's hard or if it's soft, is a part of the file system. So by addressing it with a path, you maybe write the screen. And Inferno is an even successor of Plan 9. Acme is a very wired editor. A colleague of mine uses it. Yes, it's really wired. Limbo is a concurrent programming language. Could be seen as predecessor of Go. And UTF-8, yet the encoding should be well known. The encoding of chars, potential chars, from 8-bit width to 32-bit width, with currently up to 64,000 different charts that are defined in the standard. So Ken Thompson and Rob Pike together had designed UTF-8. Yes, and the Turing Award, you don't get that every day. Yes, and that is the goal of Go from the beginning. The idea of building a safe and performant language, like it sealed, but you have the comfort and the expressiveness of dynamically typed languages, like Python, for example, and that's what I really can say from my point of view. It is fast. I can show it to you later here, and it is very comfortable. In a way, you don't have to write much code to get to your target. And it's a system language. It's no language currently for building applications with a graphical user interface. There's no stable binding. There are some community bindings to GTK. I don't know. I think so. But mostly it's used on the server side and for web applications. And the standard packages support it very well. So here, a typical hello world. Even if it's too expressive, it could have been shorter. It's a simple print statement, but it should show you that the code is organized in packages. There's one special package. It's called main. This is a program you can call, and you can do your own packages. You can import other packages with a simple name that is one of the standard packages for formatted output, input-output, or external packages from third-party developers. It's also pretty simple. Yes, function declaration is very short. Here you see that the type of a variable is set after the name of the variable, not in front. Yes, I think that is very special here. Formatted output. Here, the variable 2 or the parameter 2 is input as string into the S string into the string. And so say hello here below. The main function is the one that is called if the program started. Calls say hello world, and then the output is hello world. It's a bit complex for this example, but I want to show you the part of the software. As you can see, there's no return type and there's no argument. This will be handled with packages. So it's simple. Yes, the roots are in C and in the concurrency of 29. There are many similarities. It compiles to native binaries. That's very important. Currently for Linux, for OS X, for Windows, for FreeBSD. Current supported, and on Intel AMD architectures and on ARM. As far as I know, there's an ARM port too. It does static typing, and it is very keen in static typing. So if you have integers of different sizes, like integer with 8-bit and integers with 16-bit, and you can't assign them without casting. You have to do it right. Concurrency in the language is very important. It sounds harder as it is, but because you mostly work with a pure int or you work with an int 64, so don't worry. Concurrency is very important. It's yes, an adaptation of the changing world of what we have with multi-core computers. This little box here does 8 hyperthreads in parallel, so you need the software for the right hardware. It is very much interface-based, so you define interfaces for types, and you will later see what interfaces are. And this helps to structure the software, like we're going to do. You get a set of powerful tools to build software, to test software, to get a format of the software that is common over almost every source you find on the internet, because everyone uses this tool. So indentation and alignment and everything else is everywhere okay. That's really, yes. It has been a hard discussion point in the beginning because there are many people who want their own format, but yes, this tool is better. And testing, I said, installation, retrieving of external packages and installation in the own system. It's with one tool, with subcommands. It's simple. Yes, and it's, that's hard to say, it's no fantastic new pure language. It's nothing really new. Mostly it's known from, yes, concurrency is known from Erlang. Erlang is more than 20 years old. Parts of object orientation, it's no real OP language. It has parts of it. Smalltalk is 32 years old, even older. Smalltalk 72 is yes, an even older standard, 40 years. It has closures and higher order functions. Greetings from this. So there's nothing really new, but it's pragmatic. And so I take a quote of Oscar Wilde. It's better to have a permanent income than to be fascinating. goes no language to yes, hey, I've got a pretty cute language. It's just a good language to work with. Yes, you have a large set of standard types. There are, they had a name for it. I don't remember, right? No. Those are types you can directly use. So you have a typical rule with true and false. Rune is an UTF-char, a string, an unsigned integer pointer. Here you see unsigned ints from 8, 16, 32, 64 bit, with the same with sign. Two types of floats, two types of complex with real and imaginary type. And you have types that you have to define. They had such a cute name for it. They are in the presentation notes. Let's see them. But you get the presentation with the presentation notes, so you can read. So you can build an array of runes, or makes no sense, an array of string or slice. Slices are very important. Slices are arrays without a fixed size. Maps are primary data types, dictionaries, hashes, called otherwise. Pointers, but there are no pointers to the memory. Pointers are more in the sense of references to an existing variable somewhere else. It's needed to, yes, you can't set a pointer to any address in the memory. You only can set a pointer that can be used, for example, if you push it via a channel, you don't have to copy the whole data, you only push the pointer and then the receiver can handle the data. So that's the pointer. Functions are primary data types, and that's interfaces, I told you, because we'll see later more about it. And channels for the communication between Go routines. So routines are the parallel executing units of work. Yes. What's nice is you can declare your variables almost as usual. You have the keyword var, and then you get the names there and the type. But then later on, but mostly it's done with the old sign here that is known for, yes, for people who use Pascal or maybe two. But here it is an implicit declaration and initialization of the variable. If the system knows that this function returns, in this case, an int, why you should write that this is an int? It isn't int. Or here, this term says I have a slice of strings initialized with 2 strings in it. So why should I write it? I see it. Or a map structures everything. Or, as you can see here, go use multiple return values. So here you have calling of a function that returns 2 variables, and both are assigned the same name. If you have questions?
Yes. Just the equal sign on top does not initialize the object. Just
no, here you have already declared it above.
Okay.
So you just assign this. This equal sign is a typical assignment of an already existing. So if I do an initialization or declare an end initialization in one step here, and later in the code I will assign a new sign to a new size to the variable s, then I have to use this equal sign. It is a simple assignment.
but the compiler will warn when I try to assign a new type
Yes.
to an existing data.
Not even one. Stop.
Oh, okay.
It's hard to write code in Go that is, where you are unsure how it will behave later. That's why I said, even in types, it's very keen on that you're using the right types, and here also. Or if you have names there where one name hides another name.
So there's no super type, like in Java where everything's an object? Okay.
No. There is a type, we will learn it later, that can work as a kind of, any type. But here you have to declare it as this type, and then you can later make an assumption which type this is and work with it on. So, why I said it's almost object-oriented. Types, every type can have methods. You can't add a method to an existing type that's from a language itself or from another package. But if you have an own definition, you define white as a type float 64, then I can assign a method, here the message is string and return the string, to this white. So if someone else takes white and makes an own type named foo, the type white, he can also add a method to this type, but not to white itself. You have to do it in your own package. What you see here is also, this is a very important method that many types have, because this method will be used from the format. This is the FMT package you've seen in the beginning. When printing a variable to get a more expressive output.
Like to string job.
Yes. But it depends on it's very different. And you see here the asterisk. The asterisk here in this case is just if you don't take an asterisk here, that's what I said about pointers. If you don't put an asterisk here, this n, here in this example of name, will pass as copy. So if I do a set last here, it will be done on the copy, but not on n itself. So it doesn't work. So at least for all, where you're setting something, you have to take a pointer. But it's very common to everywhere use a pointer right now. And what you see else here is some methods and types are written in uppercase and some lowercase. But you don't see anywhere protected or public or private. Go differentiates only between package private, so something is visible all over the same package, or public, and everything that's written in uppercase is public, so it will be exported to anyone who imports the package, and everything that's written in lowercase is package private. So in case of when I have a package where I define the name, this name is exported, so another package that imports my package can use the name, but it isn't able to see first and last. They're in there, but it don't see it. And in this case, very often when it doesn't hurt that fields of structs are public, they are written in uppercase too. But in this case here, for this example, if you need getter and setter, also standard is to write the setter with set class, but the getter with class. No getter. That's just an idiom. It's common. In the beginning, it may be a bit strange. For everyone who comes from Erlang, it's well known, so no problem. Yes, object orientation is not existing in this way. You have inheritance. There is no inheritance in Go. If you need something like that, there is type embedding. So here, for example, I've built a base plate as a fundament of a box, and it has a function returning the area of the plate, and my box uses it too. So I just embed it here, not as a own variable. I directly embed it here, and I can address this method here directly and multiply it with the height. In case of that box itself, also want to declare a function named area. It would also work, but in this case I would address here b.baseplate.area. What I can do is that that the embedded type has access, for example, here to the height. That is not possible. But there's a dirty trick. You can define an interface where baseplate is defined. An interface for those methods that lets you, for example, return a height of something. And in the initialization of box, you pass the box instance to baseplate, and baseplate implements this interface. It's a dirty trick. So forget. You come later. Also, there are no constructors like known from O languages. You simply create any function that returns an instance of the type. So here I just create. This is a shortcut notation. I could do my variable gleich new base plate. There's the keyword new, and then I can assign the width and I can assign the depth. But this is a short form of writing it. Return a pointer to the new instance of base plate where the fields are initialized in order with a WNT. It's a simple form. And here, I just have to say this is the base plate because it's embedded, and the height is the second. There are very often, when you are inside your own package and you have private code that won't be exported, that you directly call this one. Only if you have more complex situations, like you have several fields to initialize. Maybe this illuminated box has several fields more, but you won't initialize this in the beginning. That's an important fact. Every variable, every field inside the struct, everything is well defined, initialized, even if you don't assign a value. So a boolean, for example, is always false, the string is always empty, numbers are always 0, so you can, you don't need to initialize each variable. The pointers are always nil in the beginning, so that will be there on every platform, every And here you see
I have a question.
Yes.
And so there's no null value which I can assign to string?
Not a string. String is a string.
Okay.
But there's a nil for a pointer type.
Okay. Only for the point.
Pointer and reference types that are channels and slices. They need to be created because they have explicit. Just take it, they have to be created. And here they also would be nil. But you can't assign nil to a string, or you can't assign nil to that's not possible. And here, that's also typical if you have a type which instance has an assigned Go routine as a backend. The Go routine is the current part that works in the backend and does things asynchronously. So here you do such a kind of constructing or creating method. But there's no real construction.
I have a question.
Yes?
In the second example, there is W, D, and H, but the first two don't have a type. Does that mean they all are float 64?
Yes. Yes.
Oh, okay.
That's why it's so good to have them have the type afterwards. It's simple to write it this way. Or other way. Would it be also possible? I have to think about it. But this way it's yes, handy. Interfaces, I told you about it. They are an important abstraction in Go. They do something like duck typing. An interface is, yes, you give it a name and you define a set of method signatures. And you don't have to tell anywhere that the type you are now declaring and implementing implements this interface. Unlike you know from Java, where you have to say class implements foo, you don't do that. Just implement the method, it's okay. So, to be the duck example here, I just have there a type duck, that's an interface type, with only one method, the method of quacking. Yes, pretty simple. There are very often so few methods in the interfaces, but one type can implement several interfaces to build a larger set. So the user of the interface, for example, the I/O writer, I/O reader functions, or I/O write and read functions, just use the write and read interfaces. So they're very concentrating on a small set of methods. And here are two implementations of Quark. One of the simple duck and one of the complex duck, who's living in a living box. So, yes, it's nice box. But both do crack. So if I have a pond where several ducks are living, I have a nice function to add several ducks to this one. I don't mind which kind of duck this is. It can be simple, it can be complex, it can be any duck. It's only important that it's a duck. Here you also see variant parameters. They are passed as a slice of ducks. So as you can see later here, you can add several in one step. This is only allowed for the last parameter, but yes, I could call it with 0, or I could call it with an int and a 64-bit computer. It would be large source code. Yes. simple. So here I'm creating a new point. As you see, your constructor, I just do it directly. DAX is automatically, yes, you have got the type above. And this append here, even if the DAX is not yet created as a slice, automatically it does it if DAX is 0. Oh, I have to create it first. Empty slice and then adds all those DAX. So here I create, here we do in blue, also those who don't know them in German, tick, trick, and track, and add them to the slice. Here's the next nice command. I want to get all those DAX out of the slice and let them crack. And so I range over the DAX and yes, I get the DAX as instance. This one is the operator for I don't care what is returned here, because range returns the index from 0 to length -1, and the DAX is the instance of DAX, so I don't care, and this is an underscore. And I can print the clock of the DAX.
I have a question.
Yes?
Sorry to interrupt.
No problem.
If you don't specifically define which interface I'm implementing, how do I know if there are two which have the same methods with the same return type? Which one I'm actually implementing?
Why do you care? If there's something that quacks, it's okay.
I care when I make such a call like p-add because they all have to be of the same interface type.
Yes, that's what you define. You only care for that whatever you add, have to implement the interface there.
But if in my method add I use a function that one interface implements and another doesn't implement, then I can have a problem.
Maybe I don't get you right. What kind of problem do you have? Can you try in other words?
So if I have two interfaces, they both implement quack,
yes,
but one of them implements something else, another method, and this method is required in this add function, then if I give in a function that implements the wrong interface, it doesn't implement.
Here in this, I'm using that because I'm only care for this only quack. If I have to, or if I'm interested in using here this slice of any type that can do more than just quack, flight or something else, I would define a different interface. I could, for example, create a new interface, flying ducks, where one interface is duck and one interface is flying. And both are embedded, so I have a new interface flying duck, and I only would use flying ducks here.
So then the compiler does this cross-checking to see which methods are used in which interface.
Yes. So if I would call here something that isn't possible on the duck interface, you would just throw out an error. So he's only interested that you provide the right methods for this interface you are addressing here. And if you don't provide this method, it's an error. And if you provide more than this method, but you don't use it, it's okay. He's only interested in these things should quack.
So another question. You use the methods range and append. Are they in the global namespace or something like this, or do I need to import them?
Yes, letter-known methods. It's not a pure object-oriented language, it's an imperative language. So there are several functions that are on the main level, like this println here, append, copy. Append and copy are for the work with slices and arrays. You have delete, to delete something out of a map. So there are several functions hard defined that you need every time or more than once. So you just don't put it into a package. I told you about a special interface or a special type. It can be anything. That's this ugly type here. The empty interface. The empty interface is, hey, I have a type that have no method. Or I don't care which method. That's any type. They could have called it any. There have been discussions about why do we call it any. But they wanted to expressly show this is an empty interface. So you can, if you have a variable of a type empty interface, here in this case, I would, for example, write var e interface and then a curly brace, or var e by anything. I could assign anything, really anything. But then it's a problem, how do I know what's behind it? And there you have two special statements that are helpful. One is a type switch, where you say switch. Here I have, oh, the typo. This should have been any, not any. With this statement here behind, do a type switch, and then in this one, this value v here will be initialized with the right type. So in case it is a bool, you can handle it here like a bool. You can every Boolean operation, do every Boolean operation on it. Or if you have defined your own type, this can be a complex struct with inner structs, with maps, with slices, with everything. And you say this any here which we pass is this complex type. You can use it as a complex type. So this type switch allows you to determine what, in this case, any is. And if nothing matches, you could also have a default branch and say, oh, I don't know what it is. As a short interrupt here, you already see it first step of error handling in Go, and later see it how working. There's a type error, and you can create an error with errors new. There's also another way to do it. And if you got any error, you return with this error. Or if there are no errors, you return with nil. That is a common pattern in Go. Why you will see it. In case you are only expecting one type here, you don't have to use a type switch. You could also do this way here, where OK is a Boolean variable then, and you can check, is it true? And if not, oh, I had expected here a wanted type, but it is no wanted type. It is something else. So this allows you shorter ways to get it. But yes, interfaces are a way to get some kind of generic programming into Go, but mostly you shouldn't know it. You should really think about when you want to use it. The type safety is one of the very good features of Go. So using the empty interface should really make sense and should be thought about twice.
Another question? Yes. You have defined interface and then curly braces and what line where you define function foo. Is it possible to define something like an inline interface where I don't have to write like my interface name interface?
An inline interface? No.
Something like creating an inline type. Or so on demand, where only you have to define the interface type inside the signature of the function.
There are anonymous structs that can use inside of functions, but there don't no interfaces, and you can't build any functions methods on it. But you could then, in this case, create a higher order function that works on each other. It is a bit dirty, but yes, on the trick it would work. Funny, never needed it. Functions are the right topic. Yes, Go has a flexible word of functions. We have first class function. We have seen them just with func and then anything else. Higher order functions you can pass around. You can define your own function types and use somewhere else. Function literals directly in the code. That is what QEMU is about. Closures that you have access to the surrounding context. And functions can have literal return values. So here in this case, for example, the duck action is any function that it can get a duck, take a duck, do something with it, and returns an error or nil. So my definition of function type. And then on my point, which I had defined before, I have a method that does do the action. I want to say, in case instead of arranging myself over all the ducks, I want to have a function so that I can pass a do action, and that will be done for every duck in my point. And here I also have my error returning. So here inside I do the range over the ducks. This is a public function. Otherwise, this ranging wouldn't have been possible for other packages who are importing when we have my point. I range over the ducks. I execute this action A. I possibly get an error. Now something neat. I put a semicolon here and can check if the error is nil or not. If it's not nil, I return the third error. And I just see, I have to get over the code. I'm missing a return nil here. Because if I have a function with a return type, go explicit when I have a return at the end of it. So big is a return nil. And now I just wanted the quarks of all the ducks collected in a string of slice of strings. So I pass my pond. I build an empty slice here, an empty slice of string. This one shows it's empty. Then I call my ducks do. Have a function literal here, directly defined here. I could also define it here as an extra variable and assign it. Or I could build it on the outer side, but I do it here as a literal. The function has this signature above, so it's a duck action. I can pass it here to let ducks do. Internally, I take this quarks here. This is my closure. And append this what races are missing. Because sadly no syntax control here in Keynote. And return nil because I have no error. And in this case I can't have an error, so it's no problem. But when I would have an error, I would return a nil for my slice and the error, so that the caller of collect quarks sees doesn't work. And if it works, I return the quarks and nil error. So the caller could see, like here, error is unequal nil, so it's okay. It's a bit heavy in one step, so you take these slides later, but it's everything in one way. Function literal, closure, function types, first order functions, higher order functions. hope it's okay.
Two questions.
Yes.
How do I assign, when the return values have, when I have multiple return values, how do I assign two variables on the other side when I call the function? In the same way, would I,
yes.
would I
As
type
you see,
quarks?
as you see, here in the post 9.
Okay.
This would be my collect, and then I have this thing here. This would be the crux, this is the error, and then here immediately direct, immediately after, I would check if error is nil, and if not, I would do error handling, and otherwise I can go on. But there will be a few slides about it.
And my second question is, do slices have methods or functions?
If you define so, yes.
Okay, but not in the standard level.
The standard slices, because there are no hard slices. Slices are just yes. You define your own slices of strings, of ducks, of anything else, and you can work like here directly with this here. But I could also say duck set. Duck set would be a known type that is a slice of ducks, and then I can add methods to duck set. So this is a bit like here what I've done with Pond, but Pond would have several other fields. Empty interface, functions, yes. Concurrency. These I took because they are very good, yes, visualization of what concurrency means. Yes, in Go there are, the Go concurrency is based on Go routines. They are co-routines. On Erlang we would say processes that are lightweight processes or lightweight co-routines that are running and multiplexed in a thread pool. So typically the backend creates the optimal thread pool for your hardware, and then you can build your Go routines in it almost as much as you want. Up to thousands is almost too few. There have been posts in the net about several hundreds of thousands. And Rob Pike himself once told that in the debugging session he found that the system run 1.3 million Go routines on a standard node. Why that is no problem is shown in the next two slides. The synchronization of the work between Go routines and the communication is done via channels. They can share memory. Sometimes they work on memory that is, yes. Think about a large slice where several Go routines handle different parts of the slice. If this can be done independently, this is no problem. So you can work on from the semantics here the same memory, but you don't share data using memory. You share information and data using channels. And what is different from Erlang, an Erlang process has one mailbox. So you have got a process ID, and you send messages to this process ID that gets into the mailbox, and then you fetch it, you do your pattern matching and handle of the message. Here in Go, you can have multiple channels that aren't owned by a Go routine. They are standalone, like highways, and there can be several Go routines, several channels go in one Go routine, could be used by one, or you can have one channel that is used by several Go routines for load balancing, for example. So There are several very different scenarios. What's very important, concurrency is not parallelism. While the concurrency is used is used for structuring software, for the composition of units that work independently on a greater task. That is like the bees. There are some who collect honey, there is a queen, there are what do you call it, Wächter? Guards, the guards in the, yes, they all have different tasks, but they work together. And they work independently, almost independently, and from time to time they're communicating. That's concurrency. While parallelism is yes, used to try to split larger tasks of work into the same task into smaller tasks to run parallel on computer complex like a huge data center, for example.
So they run between different computers? Or so is there inter-computer communication
yes, now in concurrency or in parallel?
In concurrency.
In some language, yes. In Erlang, for example, that can do it directly. In Go, you would have to use packages for it.
Oh.
It's not part of the language itself. But it's important for the mind to think, yes, the idea behind concurrency is more about like object orientation. I have many objects who are working together, instances, and when they get their, today you say method call, in the early days NOK said they get messages and they process those messages. And that is the same here. But they are working sometimes asynchronously, independent, and sometimes they are working synchronously, and you have to set up mechanisms where the caller of the sender of a message waits for the response. But you can do, for example, other stuff meanwhile, and then later get the response. So the idea behind is that in our modern world we have applications that deal with lots of things at once. Network connections, high user load, network distribution, data distribution. I have multi-core computer here, we have multi-CPU in data centers. So you have to write software that can handle that. And the idea of concurrency is to structure your software that can deal with those environments. So what is a Go routine? It's just a function. Pretty simple, it's just a function. The trick is it will get a Go routine the moment I put it in the background with Go. Then that's a keyword, and in this moment this function will be handled in a new spawned Go routine, and the program here immediately continues. That's pretty simple. This is kind of linear Go routine. What you also see here is that will also be covered in error handling, the nice statement defer that will be used to put function calls on a stack and LIFO order, and when the function will be ended, regardless if it's an error or if it's a panic or if it's normal ending here, it will be called so when I open a file here for writing into it, I check if it is okay. If not, here I do logging, and in this line I know it's okay because I had no error. So I can put the closing of the file at the end, and I can go on and work, and I don't have to care file and forget for closing this file. Regardless if I have a write error here below, if I have several other steps below, if I do some calculation here below and have a write by 0, the closing will be done every time. And if I have a second defer later, because I not only open the file, I also open the network connection, I will put a close of the network connection afterwards, and then it would, in case of an error or in case of the return of the function, it will close the connection and close the file. It's used very, very much.
Question.
Yes.
Does the Go keyword return something like a promise, so I can ask when it's finished?
No. Now you have to take care of its own mechanisms like channels. You will see. Okay. Go just puts functions in the backend. That's all. So here a pipeline coroutine that uses a range statement. The range can not only be used for slices, as you've seen before. It can also be used for maps, when it's returning the keys and the values, unordered. And it can be used here in case of channels. These errors show that this is the error that can't be written to, and this shows that it's the channel there you only can write to and not read from. You don't have to do it, but you can do it. And so here I range over the in channel, and as long as the channel isn't closed, I wait for the next value. And then here I simply do a to upward the string, for example, and the output I put to out. And here I create buffered channels. Channels are typically created without a buffer. So if you want to write into a channel, the code blocks as long as on the other side no one reads it, and when it's read, then you can go on. But with a buffer, as long as the buffer isn't filled, you can write in and go on. Then I create the pipeline here, and out. And then I could, here I only have one example, I put in the lowercase string, and I read, this is I'm writing here, and then I'm reading to S, and I get lowercase string in uppercase. But I also could have a larger loop here, reading from a file and piping all my strings in and reading afterwards from out. So this pipeline is one step in complex structures where you combine several pipes, for example, as you will see in a few moments. Because one can do a very naive approach where you have synchronization problems. I can say, hey, my job that I have to do is I get something from a source. It doesn't have to be channel, it can also be any other data type that delivers data. I have to write it to target, and it contains four steps inside. And I want to have it faster than before, so I go and put some jobs in the backend. So one problem is I have now in this scenario to synchronize my reading from the source to the mutual mutex. And I could have the problem that one of the jobs, because I don't now know what steps they are, needs for one data longer than another one. So I get all my data maybe scrambled, not in order. And where do I now know? Because when I send all those 4 jobs in the backend, this function here immediately returns. How do I know that the job is done? So this is a very naive approach leading to errors or to problems. But using pipelines could be much more simpler. In this approach, I create a few channels and I write my first part so that it reads from the source and writes its results in the A to B channel. Part B reads from the A to B channel and gets into C, C into CD, CD writes to T. And so I have a kind of pipeline of several steps. And when everything here is read, then I close this chunk, which is a signal for this one. Oh, I have the last one. I can close this, close this, close this. And this one here can't close T, but it can close a wait channel that I have here. And here below, I just wait for this wait channel. I just use it for signalization. I send it true or send it false. I don't care what I send. I only have to send one. In this moment, concurrent would end, and I have proper ordered results in target. And if my hardware lets me do 4 parts in parallel, this part A can work, or part B can work well, while part A is already reading the next part of the source. It's like a factory. In the case of the illuminated box example, I showed you I start a backend is coroutine with a constructing method function, and this would be, for example, such a backend function, and it selects several channels it has internally. So here I address the internal channel, and I read requests and use an own private method to handle this request. Or if someone wants a configuration change, I have extra type, an extra channel for it, because the type of the configuration channel is a different type of request channel. This may be once again a Boolean. So if I have a public stop method, I would send it true on the stop channel, and the system here below knows, yes, I stop. And I also could work with timeouts. In the time library or in the time package, there's an after, and after 5 seconds, I call handle timeout, and yes, I can do something else, or can write a message. And I can even put, if I wouldn't have this one here, I could also put a default here. And in the default case, if there's no message from here, I would go into the default branch to do something else, do something in the back end, and then if this is done, I return the next loop and look if there is something to receive. No, okay, once again the branch. And so I can build scenarios with a lot of channels where I receive from, but mostly we have only P1, and you put more details about what requests are, the request type that will be received here, and handled here. I show you this example. This is so the typical idea of yes, you would have a kind of Java object or Java instance where every method is synchronized. So if you call a method of X, one of the public methods, it would create any of the messages here for the backend. And this loop here, this endless loop, takes care that only one at a time could work and change the fields of my instance. So I can't have overlapping access. This is very often kind of server scenario. Here, for example, I have my function that returns this string. As defined as request type, we have passed the function to the backend and the response channel for returning the response. And here now I have a very useful function of adding an exclamation mark to a pass string. Okay. So I create this function as a literal, put it into my request, and add. This should have. Create a channel of string for the response. Send the request via the request channel to the backend. And then I wait for the response that is delivered. And as you've seen on the slide before, it would lead to this handle request. And this handle request is here below. My response is executing. Yes, I have a type error here. It should have been string. In my former example, I used a larger response with passing arrow codes and everything else, but it has been enlarged for the slide. I create a string by calling this function. Here, this is just to show you, in this case I can manipulate a field of my instance because no other function or no other method on X is called now. And then I send my response over the response channel. I will get it here and return it here as a string. So while the adding of the exclamation mark isn't the very interesting part, here the change of the field or other fields, maybe several fields. Think about yes, we have a kind of server instance, server routine, where you change the configuration. It has to be changed at once. Bindings of addresses, of ports, bindings to databases at the back end. You don't want to have to do it set, and then meanwhile you get a server-side request and through everything and here you want to just send the configuration at once, change it at once, and then return. I also told you about load balancing. With a balanced worker using pipelines again. Here, any worker. I create channels to write to the worker and get the results from the worker. I have the empty curly braces, an empty slice of output strings. I create here 10 workers. I put them in the background. I put a function in the background that that reads from the input string slice the input strings and writes them to the in channel. So a free worker can fetch it. All 10 workers listen to one channel, and they're fetching the work if they have nothing to do. Inside of the workers, like the pipeline I showed before, a loop listening for if there's something to do. And when I've read all, I close the channel, and this is a signal for here to see where I get the output strings. I append them, I collect them, and if I have the same amount of input and output, I break here, and I can return it as my value there. I don't know what the worker does with it. That's not important. But it shows I can also easily create parallel tasks working with tens of customers, just one data type to maybe do all those upper cases or something like that. But take care in this example here, if one string, for example, has the size of several hundred megabytes, and one string is 2 bytes, we'll have runtime differences. So the order will be, or can be different in outs than in.
So are the channels always thread safe? Don't you just mention anything about them? So you know that they, not two workers will pick up the same message from the channel at the same time.
They are thread safe, yes. Go routines safe?
Yeah.
Yes, only one at a time can read from a or write to a channel. And now typical scenarios you also need in server environments is if I'm receiving data from a channel, it also can be that while I'm waiting, the channel is closed. You already have seen that then the workflow would go on and the assigned value would be nil. But it could be that I want to explicitly know that it's closed and not check for nil, because nil could also be a valid value. So I have this statement here, and at the same time I could also do a timeout. Mostly Erlang developers know how important timeouts in server environments are to yes, if there's a Go routine which is adding data to data chain has a deadlock, you don't want to have deadlock here too. So in this case you will be notified after 5 seconds, and then you can do your own error handling. Or when I'm sending data, it could also be that the receiver of the data has a deadlock or something like that. So I want to write my data, but you can't get it. I can't write it. So yes, I would wait until yes 1990 minutes, and that's too long. So once again, I add a timeout and can end gracefully. Yes, as you've seen, Go doesn't know exceptions. There's a type error. Error is just an interface with one method. The method is error, it returns a string. In many parts it's just enough to notify here's something that happened. There are two convenience functions to create those errors new or FMT. We form a package as an error f where I can use the same rules as in print or sprint, fprint, the same rules to use placeholder in my string and replace them by variable parts. But every time it's only a string, so if this is not enough, there's no problem in defining an own error type, which can have as a struct several fields with more important data for me, for the error receiver, and it only has to implement the error method to put out a nice string, and the other parts, the other fields I would make public, for example, so the receiver of the error can look if the type of the right one. Oh, this is a timeout error, this is a file system error, this is, I don't know what an error, and can then handle it the right way. As you've seen before, there are defer statements to put functions or function calls in the backend. So the leaving of the surrounding functions, so they're very good for cleanup tasks. There is a built-in function called panic, this is a real hard panic. This is where very often in Java programs exceptions are used by far too much. Panic is a real hard error, a real hard failure. It should be used with care. This is so that in the logic of this program, this really shouldn't take place. A broken network connection is no problem. When a file system is full, okay, I can write an error, add another disk or so. But I can also do something that is really, from a logical perspective, bad. And then I would throw a panic. But also those can be handled with a recover statement. As you will see, those three together defer with the recover and then insert end function, and panic help you to get in a safe way out of the panic situation. And yes, on the mailing list there are many discussions from beginners. Oh, no exceptions. How should I do it? How should I live with it? Finally, this way of immediately checking if there's an error and handling it leads to very clean and good design. It's hard to tell why. Yes, I am working in a team with 5 members in Brazil, Malta, England, and Australia. So we don't see us every day, but we produce code altogether, which yes, it's easier to read and understand because you have a control flow in your functions. In this way, that you don't have very nested code, you have very linear code, where you immediately check if there is an error, and you have your defers to clean up situations when the function is left. So you have a very linear and unnested code, and that is easy to understand. So here is a short example. I have my own little non-feasible duck error because I have defined an additional interface combination of my own duck interface and feedable as a second method, and my pod only has any duck, not only feedable ducks. So here I implement the error method. Now this is a valid error in the sense of Go, and I have a function feed ducks on a pond with this food. So the well-known let ducks do. I run over my ducks here, and oh shit, here's a duck where I do a type assert. You have to be a feedable duck, but this duck says no, and no feedable duck. And if it's okay, no, sorry. Here it says okay, so I feed it because due to the type assert here, fd is a feedable duck, and I can call feed. That's a new defined method on feedable duck. But in case it is false, I return the non-feedable duck error. So I create an instance of this error, and I pass my duck the food. And now the caller of this function here can check is error nil, and if not, you can do a type assert on the error and see, oh, there's a non-feedable duck error, and you can see which duck it is and which food doesn't want. And the left. I think we are through with the moment. Yes, that you just should show the typical handling. What I said was multiple return values, and the last one is very often error. And in this case here, I do a network dialing with a TCP protocol on this network address, like localhost 80. Or I can't call it because I don't have a server here, so I return this error and nil as my data. Otherwise, I defer the closing of my network connection. Then I do the retrieving. I load the data of the protocol that is expected. Maybe there's an error too. It would be somewhere in there. And if everything is okay at the end, I return my data and nil error. So in somewhere else in the code, I have the caller of my function with a multiple assignment here, and it immediately checks if the error is nil, and if not, then it handles the error. It maybe just do the same like here, because it is no error handler when you pass it. Or you have a kind of built-in error handling in your application and pass the error to this part there. That depends on your code. It's a system level. It's no high-level language. It's a system level language. But as you can see, then the next part would be open a file here or do something else here. For instance, not retrieve. You could also write data, and you have to open a file where you read your data from, and then write it to the server with the same. The next step, open the file and close it afterwards, do the error checking in between, so you get a very linear code and not very nested. If this and that, and oh, else and no. Yes, panic and recover. Yes, it's have a same execution of a function with this signature. I defer function literal, where I call internally the recover function, that is one of the built-in functions. And if this, what I get from there, isn't nil, I know I have a failure, and this R here describes it exactly. And then I could call my function that I have passed here, and when there an error happens, the defer will be called. Defer will be called. Oh, it's not equal to 0, not equal to nil, and then I could print out to the log. And here I have such an example. I will have it divided by 0. That is a typical panic situation. Funnily, I can't write 0 here, or 0.0, because the compiler throws an error. This way it works. But in this case, yes, the whole application wouldn't abort and wouldn't print a stack trace. By the way, the stack traces of Go, even if there are several Go routines, are by far more readable than of Java, because the individual parts are very near to those places where the error happened, but not very long stack traces. It only can be very bad if you have, I don't know, never tested this with several thousand Go routines. Okay, so this is also pretty nice if you have a type like you've seen before, where you have a backend and you have your fields as variables of this type, and the backend runs, and then there's something like an error there, a hard error like this one here. Typically the Go routine would stop working. You panic and Go routine stops working and everything will stop working. But if you put this mechanism here of defer and recover inside this backend Go routine at the top, you could catch it, log it, and then just restart your backend. The only thing that you could have is inconsistent data, because you don't know where the panic happened. If you want to have this way safer, you would have to work with a second global team managing the data, and you're only making data set. So you process in one, but the data is stored in the second one. Or you have to copy your data, then work, and then copy it back. Both are ideas for very secure software. Oh, almost the end. Yes, if you go to the site golang.org, there's a very good documentation of all those packages that are inside the standard. I only took some groups here. You have networking with HTTP and HTML templates and text templates. There's a template language inside. If you're interested in the example code later, I don't know how later, I will show it. Encodings in JSON, XML, or base64, something like that. This is built in, very simple I/O, informative, crypto, very much crypto routines. Imaging, time library that is with reflection, Go also knows reflection. It isn't used very much, but you can do so, yes. You can use reflection. External packages. As a naming system, you've seen import in one of the first example. And the standard packages are just imported with the name. If they are nested, you can have import net slash net slash HTTP. Yes. If you have your own code somewhere else, or you use code from someone else, there's tooling based on source control management systems like Bitbucket, GitHub, Google Code. Yes, my Thailand code. Anyone knows what Thailand is? It's not only my software language, it's an English name for the ecosystem, Buttonware. Launchpad from Canonical. And you also can define your own public source code management system based on Mercurial or Bazaar somewhere. And then you do an import with the full hosting Redis, and then for Launchpad is launchpad.net / then the package name. I'm hosted at google.com, and here project Thailand CGL, common Go library, and there subpackage Redis is my Redis client. And when you have this in the import statement, in this moment you could use it in your code with a prefix like you see in the usage of time, in the usage of format, with Redis as a prefix, and then dot and the function or type name. What you want. The Go tool. There are some tools beside the Go tool, but the most important is the Go tools. This is one tool called Go, that has several subcommands, and there is Go build, for example. So you have to keep a kind of directory structure, and then if you go into your code directory, you do a package directory, all your package files have to be in one directory. Make a Go build. You don't have to write make files or anything like that. Go. And there's also a Go run, and it builds and runs immediately. You can do Go format. I told it that formats all the source according to the standard. So if you browse Google code that's available in the net, you can read it almost immediately, as long as the naming of variables and types is useful. Go test, there's kind of unit test framework. If the code isn't built in the moment, when you call a Go test, it will be built in the moment. If you have set the goal path, which is an environment variable, to use or to contain several paths, the first one will be used for external retrieved packages, and then you have all your own maybe projects behind it. And then with install you can not even build your own package, and you also can install it so that if I have an application A or project A and a project B, project A could use the project B files. And forget is if you want to have this one here, you just type go get code google.com pcj-redis. It will be retrieved from the code management. It will be taking the right version according to the tagging of your code and of the Go version. So if I have this code has grown over the several wikis, and also Go has grown, and if you are working now with Go 1, my software also has a tag Go 1, it will be taking the right one. It's also always matching. Or Go doc, so you can put out the documentation of the source files based on internally and externally, based on the commands of the source on the command line as printed text, or you start it as a HTTP server, and then you can browse in the code. It looks like the code documentation of the package documentation browser on the Golang side, but your own code is also included. So it's super simple. And there are several more. Good. Thank you. Yes, any questions? Many questions have been during this good.
Can you explain again, please, the usage of the keyword defer? Does it matter where exactly in the function I place it? You have, for example, defer closing of a file.
Yes. Yeah. I could have done the defer the connection immediately here after the dial. But the problem here would be that if dialing this address would lead to an error, the connection would be nil. And calling nil.close would be an error too. So the typical way is in the control flow of the application to check is everything okay, and then defer the statement to the backend, background on the stack. So it's important that this con for the connection exists and it's valid.
But can I still use con and this do the retrieving data part afterwards?
Yeah. Yes. You can use it here and retrieve data from the con, or you can write data to the con, handling the protocol, and it's a valid variable in the whole context. And regardless where in the if you have an error-free workflow, or if you have an error inside and you have to return the function very early, it will be called every time.
So it's guaranteed to be called at the end of the function, right?
Yes. Even with a panic.
So it's like final, like a final.
It's like a finally, yes. But you don't have to nest it. Because
you see no it early.
And it doesn't mean to be at the end, it can be closer to the
Yes.
the end of this object.
That leads to, because in case of finally, you may try here, catch errors, and finally you close the connection. But in closing the connection, you have to test that the connection is not razor of the error. And then, inside this try, as next step, you maybe would open a file, so you would do the next try, do the next catch of the next section, and the next finally. So you have a very fast kind of nesting of tries, catch, and finally. And here, you don't have so.
I have a question. Could you please explain what the convention on starting function names with an uppercase or a lowercase letter is?
That has to do if you as the developer of a function of the type of any identifier wanted to be exported from your package or not. If you just build typical utility functions that you only use inside your own package, or you have variables inside your package, then you write everything in lowercase letters. But if somebody who imports the package, think about this function here is in the package foo, and somebody does an import foo, then you could use foo.retrieve because it's exported. And if I have a little helper function here with a small lowercase letter that is called ensure path name, little helper that takes care that the path name is written the right way, and I will write it with lowercase, then it isn't exported, and the importer of my foo package can't see it, call it, anything else. It's just an implicit exporting of identifiers.
Okay.
Could you tell an example of a real-world application program in Go? That's
yes.
already existing or just in work?
Just one. There are several companies that are using it, like Mike, Canonical. We are building software for the provisioning of cloud applications in clouds like Amazon or OpenStack. OpenStack is the right name. That is server-side executed application that has parts in command line and in server-side agent that control if the software is still running. That is currently built in Go. But more important, do you know the Google code search that now sadly doesn't exist anymore? It has been existed until a few months. That has been in Go. Or do you know that 10% of the internet traffic currently is influenced by a Go application?
Okay.
It's a load balancer behind YouTube for optimization of MySQL database calls. And there are several other companies like how's it called, the company behind Java?
Oracle?
Oracle? Nee.
Atlassian.
Atlassian. They are using it too. And, there's a site in when I go over the slides, I will put some links in where you can see where companies are named. And there's a site maintained by Google where community developers can submit their own software, so you can see there many projects. But for a real start. Many waited until now. Go when is this problem. So my work book, it hasn't been so very much. I hope for more. Until Go 1 has been published, but from one day to another, the whole stock of anything has been sold out. Nice.
How do you do the documentation? For example, in Java, you have Java docs, so you write it in the code. So you have
it's the same here. This is the doc.
Okay. How do I do comments, or is it just
no,
comment?
This is not the declaration. There's a declaration. This is the.
Okay.
And there's no, there are no tags for declaring all those variables and parameters and return values. Typically, you use the name of the function as the first word, and then you write the whole declaration behind it. But the funny thing is that you shall, but you're really reminded to, when you have a public function, it's your API, that's what you sell, they should choose names that are speaking for themselves. And I have seen so many bad Java docs with no real documentation.
Parameter, declaration, parameter.
Yes.
Okay.
And the Java docs, the Go docs allows to not only see the comment, to see also the declaration, and if you click on it, you can browse into the code.
The build command of Go does it only create the binaries for the system I'm running on, or?
No, you can also do cross-compiling. Okay. Then you have to set several environment variables, and in this case, you can do cross-compiling. Please speak first.
No.
No? Okay.
So if there are only two scopes of identifiers, like this small letter and capital letter, can I access local variables from another function, defined in another function?
Not on the function scope. On the type scope. So if I have a type defined inside my structure, for example, defined inside my package, and the fields of the structure aren't exported, so they aren't, even if the type itself is exported. The importer of the code only sees the type and its method, the public methods, and can't access directly to the fields, but the code of the same package, even if it's in a different file, as long as the package is the same, can, if it gets past an instance of this type, it can access directly.
Yes. But some regular variable I, some counter inside one function, you can define another I in another function.
No, they are
completely different variables.
The context scope is like in C. So no, you can't do this.
I have a short question. Yes. Sorry. At the beginning of your examples with the ducks, I saw some syntax where you use curly braces to create an object which you define instead of regular braces. Does my memory fail me, or can you go back?
Panic.
When I talk about quiz structures,
like
this one here?
Here, yeah. the base plate constructor and the box constructor?
These aren't really constructors. This is a kind of short type notation that go with those. It is, yes. Regardless if you have the ampersand before, the ampersand only says I could create a pointer or I create directly how to say it, a variable no pointer of base plate initialized with those values. That is, there's no, this is only an assignment. There's only there's a reservation of the space and an assignment of the values, but there's no code executed. But here in this kind of constructing function, I want to do more. I want to do some internal constructor calling. I want to do some calculation. I want to start a backend Go routine. Maybe I want to start several of that, and then I want to return the created instance here. So this is why I created here a real function returning my created illuminated box. And here in this case, they both are so simple that you can even not write those constructors, and in your code use directly those statements. But as a problem, it is if you would create it as a function, like here, it's better documented to someone reading your code documents, and if your type, your base plate, for example, gets a third field, this one still would work, but you internally would change here is the default value, for example, and you would add a second constructor, so your code wouldn't immediately be broken. But if someone uses this direct way to create an instance from an imported package, then you would have the problem that any layout problem, or maybe you just don't turn this one. This would work still, but it doesn't make sense. So you have more control when you use a constructor function, and it's, yes, most code you will see in the net use this short way as long as you are in your own package, because you know what you do, and when you want to build a type that shall be used through export and import into another package, you create an API, and then you provide one or more constructing functions. That depends on your needs. There's an alternative syntax. It has been only available it's the only one in the beginning, where you would create a new, in normal braces, base plate, assign it to a variable, and then took this variable dot width and assign w, and dot depth and assign depth. And yes, after a short while, users of Go said we want to have this shorter, and so this construction has been created. But it may look a bit wired in the beginning, but yes, after programming some days for this, it's so free. But that's many languages.
I wanted to ask what kind of loops are there? Do while, for. I saw only 4 loops.
Pretty simple, yes?
Yeah.
All loops.
4.
4. Exactly, one loop, 4. You have to, without an argument, so it's an endless loop. a for with a Boolean condition, so you have as long as the condition is. A for with a range is as long as you get data from the range. And you have typical for I equal 0, lower 10, I plus plus, but typical counters you could do so. By the way, what's important, or what may be interesting too, for statements, switch statements, select statements, if statements, every time you have the keyword or if switch, then condition or assignment, and then always in curly brace what you do. And in switches, in those case branches, there's no explicit break like in C. If the next case comes, or if the end of the switch comes, the code ends. But you can have a kind of for through where you go through several branches in one case, top down. Cases can be single values, multiple values, can even be conditions, like you do a switch with curly braces, and then case A equal B, B greater 10, true.
So whichever becomes first true will be taken. Because more than one can be true, maybe.
It's always evaluate top down. So you have to take care which order you put it into your code. But this is a very simple and straight syntax, so yes, you don't have to think a lot about it when you read it. It's fine.
And is it possible to have a variable assignment inside an expression like in C? I don't know. A plus, open parentheses, I equals B. Close parentheses. So I assign B to A, and I also, the result of this variable assignment is B, and I add A to it.
So you mean you have a function call inside an arithmetic statement, for example?
Not really a function, yeah. More like a normal assignment. Normal assignment.
No.
Yeah.
No.
Like in PHP, typically you can do this, like, I don't know, while row equal MySQL fetch row, do something.
They don't have. For example, some real world code, just a little fun project I explicitly invented for this evening. It's a kind of register calculator where I have registers here, which map the chars A to Z, so 26 registers to big integer values. And I only can currently store values in the register, read from it, add two registers and write to the third one, or cut to one and add the third one. So it would look like that. And then I have the calculator here, which has, this is what I shown with server-like systems. I have here, for example, the command that is in private type, which has some methods here to get the output of this command, to access a register that is addressed in there, read the value, and for those who use this command to return the result OK, to return the result value, to return several values, or to return, hey, I've got an error. So I use the subtype with methods to have a convenience. And that's the whole server here below. The whole server is here, as you can see, a constructor which has some registers, the command channel to get those commands I showed above. Then I start the back end. Here's the front end, the public method to just send an ASCII line as a command. I put it inside, I parse it, I put it inside the command and send it to the command channel here. And then I wait for the result. And if the result is okay, it's okay, otherwise I show an error. And here below you see the back end with what I said before. I defer the function literal, where I restart the back end in case of an error. And here I do the switching for the several opcodes. And here, for example, is registers or move that are not built on the register itself, but I can also call it, as you see below. And here below I execute. For example, if I do a store here, this is the opcode. I here write into the register, which is in address 1, and the value is in address 2, and I write it into my register. And I send back, hey, everything is okay. So this looks, yes, a little bit of what I do here. Now I add a little web server to it. Here's an HTML template. Here you can see the whole handler of one line that I sent to the server. I sent a request and have to write a response. I get the form value. The form value is called a command. And then I send this command to my calculator I've shown before. And then I show, or get our registers to show it. And then this is just a helpful subcommand. And here in the main function I just register this my line handler to 9. And then I start the server. And if I do so, here, I should have compiled it before. It has been finished. That is everything compiled. The whole Go development kit with all sources, the C code of the compilers and everything else, the runtime, and all the packages compiled on this computer are about 30 seconds. Okay. Just an impression of how fast it is. So now I can do register. I can do. Now it's running. I can use my So this is my very complete calculator. I can do a foo in register I, the number 465, and error, deleting opcode. Or I can do number. It's an A. Then I do store B. B large number. No, not yet. It will be next. I can show you how it works. It's no problem. Add A, B to Z, and then you see it's a sequence. So I built a little calculator, and we now could add opcode by opcode. We could add macro opcodes to build something that is above the register level, or this is line-based. But we could also do it with the text area, where we have several in one step, and then we pass it line by line, execute it line by line, and have a little kind of assembler. How to build assembler in Go? I didn't thought I talked so much, so.
We'll put the source, the link to the source code in your presentation.
You said about multiply. I don't know, we'll see when we compile. And the calculator has to be Yes, so has been done. We open it. So store a once. So store B and then anything else?
I need some time to check that.
And if someone needs a good editor, Sublime Text, I think we can recommend it.
Are there packets for Go? Are
Yes.
there packets for Go?
Yes. As you can see.
Yeah, okay. Syntax highlighting, but are there also
code completion?
Code completion?
Yes. But it's no IDE, so you don't have automatic refactoring, but you can yes, refactoring by hand. Okay. Just see the.
Say something about performance.
There are official tests here on, I don't know the site, I could put the link in. It's a bit slower than Java 6 HPC or so. I don't know exactly. It's in this table ranked bit after C, Fortran, Java, and it has been something like that too. And on rank 6 or so. But it's yes. It's not yet everything optimized. Java has some time longer to learn. I don't know if you remember the time of Java in 1997. So we'll see again. Currently, the garbage collector isn't very optimal. Looks too long from time, but there is already experimental code in the new branch, so it will be soon delivered with Go with that one. But it's mostly fast enough, because performance is not only how fast I am with running through one loop and doing floating point processing. Performance is also, I have a computer with 8, 16, 64, I have a Tildera with 100 parallel processors, so I have a Sun Spark Station, yes, not Spark Station, a Sun Ultra Enterprise with 64 hyperthreads and this in 64 processors also. You have to use it. Oops. Speak more. Okay. Saves energy. So the performance of those to build applications that scale with your hardware.
Some more.
Last chance, because my train arrives soon.
Yes, I have a last question. What do I have to do to get one of the books?
I thought an idea could be that yes, everyone who's interested writes his name on a little piece of paper, and then I hope you both can organize it.
Yeah,
Otherwise go to Amazon and
jeder schmeißt sein Handy.
Wie sagt man das?